Welcome everyone to this video. Let's see what are some science facts that people generally get wrong. This video is brought to you by Question Response, the channel where you will find the answer to everything. Today's answers will be presented by Blaine Jones, Dave Concilio, AJ Patil and Mats Anderson. We'll start with the first answer by Blaine Jones.
A lot of people don't understand how Earth's tilt works. I used to be one of these people. I know a teacher that used to be one of these people, until a student corrected him as he was explaining it incorrectly. And then he spent a good few minutes feeling really confused until he grasped the fact that he was wrong. That was amusing to see. I should mention that he's a history teacher, not a science teacher, but somehow the Earth's tilt came up in history class that day. So here's the deal. The Earth is tilted on its axis at an angle of 23.5 degrees. Most people get that much. Most people know that the tilt is what causes the seasons. When Earth is tilted toward the sun, it gets hotter, and vice versa when it's tilted away. But when most people hear that, they think that the Earth, as it orbits around the sun, is actively changing its tilt. I used to think that the Earth would actually lean this way and then lean that way, and that's how it worked. Essentially, I thought the Earth wobbled. It actually does sort of wobble a bit, but that's a whole other deal, on a much more massive timescale. The Earth does not change its tilt over the course of a year. The tilt is always the same. What changes is where the Earth is in relation to the sun, and therefore which direction that tilt is facing in relation to the sun. Look at this picture. Notice that the tilt stays the same. What changes is Earth's position. Another misconception is that the Earth gets hotter in the summer because the Earth, or your particular hemisphere of Earth, is closer to the sun in the summer because of the tilt, and vice versa with winter. This is false. The change in distance, which is just a few thousand miles, negligible when it comes to solar system distances, from how close North America is to the sun in the summer to how close it is in the winter barely affects the temperature. The reason it gets hotter in the summer is because of the angle that the sun's rays enter the atmosphere, rather than the distance it is from the sun. During the summer, the rays are very direct, making them more intense, which is what increases the heat. In the winter, when those rays don't hit as directly, a single ray of sunlight spreads over a larger area, causing the energy, heat, to distribute more and be less intense. This makes it colder. Also, winter sunlight has to pass through more of the atmosphere, which filters more of that heat. I previously misunderstood both of these concepts in relation to Earth's tilt, due to very simple misconceptions. Only over the past few years have I come to realize how the tilt worked. And I think several people still hold these misconceptions. Or maybe not, and I was just stupid. Who knows?
We can continue with Dave Concilio's answer.
Bombs make bright orange flame balls. Nope. Real bombs don't waste energy on heat and light and instead try to do what bombs are designed to do: move stuff out of the way very quickly so that it is damaged. They do this by creating gas, and we have a name for this: wind. Bombs are essentially tiny wind makers. They produce a blast of powerful wind that knocks stuff over. Acids burn everything in infinite amounts. Acids dissolve some things, but many things aren't affected by acids. Glass, many stones and minerals, plastics, largely unaffected. What's worse, people think the acid will eat and eat through an infinite amount of substance. Acids follow the law of conservation of mass. If an acid is going to dissolve something, say a metal, it will only dissolve an amount equivalent to the amount of acid, as expressed by the mole ratio. In English, 1 cup of acid can't dissolve 2 tons of metal. It can maybe dissolve 1 cup of metal, and even that will take a long time. The Earth is closer to the sun in the summer. Odd this old chestnut. The Earth is actually closest to the sun in January, presently, and distance to the sun is relatively unimportant compared to axial tilt. The best analogy I can think of is sunburn. Early in the morning and late in the afternoon, you don't get much of a sunburn, the angle of light is low. But in the middle of the day, look out. It's sunburn time. There are other factors at work here, but that's the basic idea. Anecdotal evidence is evidence, aka, my grandpa smoked for 87 years and he didn't get cancer, so I can smoke and be fine. One example does not science make. Science is about patterns and trends and relationships, but also about exceptions and outliers. Smoking makes cancer more likely, but not guaranteed. Running in traffic makes traumatic injury more likely, but not guaranteed. Same idea.
We continue with AJ Patil's answer.
People get Newton's 3 law wrong. Every action has an equal and opposite reaction. This statement is wrong if you don't know the latter part. You apply a force of 20 N on a duster and it moves. But according to above statement, there should be equal and opposite reaction. Shouldn't that stop the movement altogether? Get it? Equal and opposite force should prevent any movement from happening. The part that people don't know is action and reaction always act on different objects. Meaning if I push the duster pushes me. But as 20 N is not enough to move me, net result is that I move the duster. The duster doesn't apply reaction to itself. Source: a good physics teacher. Increment $P.
The following answer is from Mats Anderson.
The base rate fallacy. The Wikipedia example I linked to is actually brilliant. Say that we have a city with 1 million people, and that 100 of them are terrorists. Say that we have a terrorist detection machine that will identify a terrorist with 99% certainty. That is, it will correctly identify a terrorist 99 times out of 100. The machine will also give false positives. It will incorrectly identify normal person as a terrorist 1% of the time. That is, if you use it on 100 people who are not terrorists, it will still flag one of them. A person is tested by the machine, and it goes, bing. Terrorist. What is the chance that the person actually is a terrorist? Correct answer. About 1%. Sadly, the same mathematics apply to medical tests, and most doctors are completely ignorant of this. If you have the same city, and 100 people in it are HIV positive, and your test similarly identifies 99% of those who are, but incorrectly flags 1% of those who aren't, then this means that if you get your test back and it's positive, it's way more likely that you are not HIV positive. But most doctors will say it's 99% likely. A fairly large proportion will say it's 50%. Some will even say it's completely certain. People have committed suicide over this. When the second test came back and proved they were healthy, it was too late.
This is the end of the video. Thank you for staying until the end. I hope the video has you more. If so, you can subscribe and activate the bell to miss any video. Also remember to leave a like. The video is over. You can continue discussing this question in the comments, or find another question that interests you. See you next time.